Welcome to another edition of Teach the Geek interviews. My name is Neil Thompson. I'm the founder of Teach the Geek. It's an online platform for science and engineering professionals. You can find out more about it at teachthegeek.com. Again, that's teachthegeek.com. Today, my guest is Dr. Karen Corbin. She is a scientist and founder of Geeks that Speak, whose goal is to help those with technical backgrounds translate complex scientific information in a way that is accessible to a broad range of audiences. In other words, she helps people who suck at speaking and she helps them get much better at it.
That's a good summary.
Indeed. I'm really interested to learn more about her work history, specifically what was the trigger that made her see that Geeks that Speak was something that she really needed to pursue. So welcome to Teach the Geek interviews, Dr. Corbin.
Hello, thank you so much for having me.
From the bit of research I did on you, I saw that you got a degree in nutrition. What was the motivation to get that degree?
Well, I always wanted to do science ever since I was a little girl. I had the little microscope set and all that kind of stuff. And when I started down the path, I'm a little old. So you picked your major with this thing called the book, that you opened and had paper and you just sort of went down. So I picked biology, which out of all the sciences, it just made sense. But then I realized I wanted to be closer to the human side of things and not necessarily so much in a dark, dreary lab on a bench. So that's when I decided to switch to nutrition. And it was a really good decision for me.
All right, but you didn't stop there. You got a PhD too. So what was the motivation to get the PhD?
So once I finished my undergraduate in nutrition, I went to practice as a registered dietitian. So I was actually seeing patients and talking to them about what they should eat. And that was back in 1998, where really the information was from clinician to patient. And there were very rigid guidelines about if you have this condition, you eat this way. If you have this condition, you eat that way. And as I started actually following what I knew, what I was taught, I realized some people weren't responding the way I expected them to. So if I assumed they were listening to me and doing what I asked them to do, which by and large, I believed so, they still weren't having the efficacy we expected. So I thought, I think we have a gap in understanding the science behind what people should eat. And I further sort of had this aha moment that all of us are different. So there's no way that there's one diet that fits all. So I decided to, after being out of school for 5 years and being a clinician, to go back to school to study the molecular mechanisms of nutrition. So what happens once the nutrients get in the body? How do they signal? What do they do? Because I figured that's where the answers were. So that's why I decided to go all the way to the PhD.
So 5 years after becoming a registered dietitian, you decided to go back. Did you decide to go back to pursue your PhD full time?
Yes.
Oh, wow. So you left working to go back to being a student. How was that transition?
It was really hard. I was older. I had been out of school for a while. So basic things you learned in undergraduate were a little dusty for me. So I'd say the first year I was pretty much just trying to recover the vocabulary, the lingo, the concepts, and catching up to my peers who maybe just had gotten out of an undergraduate degree. But then after that, having the life and the work experience became a really big advantage to me as a student. I had a lot more purpose, a lot more meaning, a lot more dedication, a lot more focus as to why I was getting the PhD and what I wanted to do with it. So it ended up helping me after quite a lot of struggle in the beginning.
For many of the people that I've had on this podcast that talk about getting PhDs, at least when they started, the goal at some point was to stay in academia. But I'm curious, was that ever something you considered?
So that really was my goal. I wanted to do research to understand the specific personalized aspects of nutrition so that we could design better interventions that eventually would make it to a clinic. So that by and large is an academic endeavor. And I'm still in an academic role as my day job. But honestly, after being in academia or academic types of institutions, I've had the opportunity to work with industry too, quite a bit more than I ever expected. And so I actually think some of the things that I'm interested in could be done in either setting. So I've never closed my mind to the possibilities of how you can apply PhD to help people. There's many ways to do that. And, I always advise students that are early in their career, don't just go like this and say, there's only one way to use these skills. Broaden a little bit, because you might be surprised what other opportunities there are out there that are a little less traditional.
Yeah, I think you're right, Dr. Corbin. In fact, I just had a conversation yesterday with a PhD, and that episode hasn't come out yet, but it will at some point. But he's a PhD in physics, and once he finished his PhD, well, actually, while he was doing his PhD, he was thinking about going into industry, and he didn't have I wouldn't say he didn't have the support of his advisor. His advisor was a career academic, so she couldn't really help him in going into industry since she didn't really know about it herself. And he didn't get all that much support from the university either. He was pretty much on his own to figure it all out, but he did. And now he really helps other people who are doing PhDs or maybe just finishing up their PhD studies to figure out, if you do want to go into industry and not stay in academia, how you can make that happen. And I always figured, even before I spoke to him, I always thought that even if you wanted to stay in academia, you may not be able to, because there's only so many opportunities for people with PhDs. And I think that there's way more PhDs than there are opportunities in academia. So then you have to really figure out what you want to do afterwards. So I think you're right. Staying open to possibilities is probably the best bet, because your first choice of staying in academia might not be there when you want it to be there.
Yeah, that's right. I think, one of the biggest challenges is funding. So you can have all the brilliant ideas that you want, but you need the funding to pursue them. And that's becoming, increasingly competitive and challenging. So even very good, excellent, talented scientists can struggle in finding those funds. So, I don't consider it a failure, or that doing something other than academia is a consolation prize. I consider, really, what's your purpose? Why did you get your degree in the first place? What did you want to do with it? How did you want to apply it? And then open up to the possibilities that could be in many different places, government, think tanks, industry, universities, all kinds of different places. So I think it's a healthy thing to do regardless, because if you're narrow in your thinking, you might miss a wonderful opportunity just because you didn't even consider it.
Yeah, and one other thing that the PhD in physics and I spoke about was, when you're in a PhD program, you're focused on a particular thing within a particular field. And so, you get down into the weeds of that. But then when you go outside of academia and you're working, let's just say, in industry, it's not really like that. You have to develop something, and there's a time limit to it. Most likely, within 6 months, a year, we have to have a product out there. So you don't have the time to ruminate, I guess, on various things and try to figure out all the various aspects of a particular project. There's only so many hours of the day, and we got to put something out there. And I think he's mentioned that a lot of PhDs struggle with that when they go into industry, that they don't have the same freedom or flexibility and time that they had when they were in academia, and that what they work on has to have some sort of value to it, and there's likely some sort of time limit to it too.
Yeah, and to be honest, I actually think you have some of those barriers in academia too, because you need to do what's fundable, and what's fundable may not be exactly what you want to do. And I actually think we need to figure out how to make science more efficient, and how to get not necessarily a tangible product, but a solution out there and integrated into a clinic, a lab, an environmental facility, to solve a problem. I mean, that's really all that science is critical thinking to solve important problems in various aspects of the physical and biological sciences. So I really think that even with what seem like constraints in industry, you're going to have different but similar types of constraints in academia. So I think it also comes down to, finding the right company that has kind of a similar vision for how science is done, and the purpose of the science. But, unfortunately, at the end of all the discoveries, there's a financial component, the money to do the work, and then in industry, there has to be a tangible product that, can recuperate the dollars that were spent on developing the product and, of course, make the company a profit. So the dollars are there in both scenarios, just maybe in a different way or a different application.
Yeah, that's a good point. So you've been working as a scientist, and then you eventually start Geeks That Speak. So what exactly does Geeks That Speak entail?
So Geeks That Speak is probably a 20-year vision that I eventually just codified into a movement. And it started actually in my days as a clinician because patients would come to me with some book that they read about diet X, and sometimes those books had valuable information, sometimes they had misinformation. And so from day one, starting, in 1998, I've been dealing with misinformation and trying to put scientifically backed knowledge in the hands of the people that come to me for help. So I've always had that passion and purpose, because it's really important for any kind of medical field to get people to understand what you're recommending for your patients so that they follow through with it. So that's been a thread that then went into graduate school when I was working in a medical school and working with clinicians, scientists, maybe also engineers, and finding when we were trying to collaborate, we may have all been saying the same thing or a similar thing, but we couldn't understand each other because the dialects were a little bit different. And so I, being from Puerto Rico and having to already translate things from one language to another, that skill actually helped me to be that translator, to say, okay, I think what you're saying is this, and what you're saying is this. And if we come together, this is what it means for all of us. So I started thinking about the importance of communicating more like within science. And also, I saw students struggle with presenting. And thankfully, with my career as a dietitian, that was a huge part of what I did, was to give presentations to group classes, grocery store tours, and one-on-one. So I had honed my communication skills before I got to graduate school. So I found myself just grassroots helping students who were struggling with how to present. And essentially, once I got to my current job in Orlando, Florida, and started working in a healthcare system, doing academic research with the goal to really get to that translation piece, right? To go from a study to something that will benefit a human, I saw just how important it was to continue to get scientists out there talking to each other more, to generate more collaborations, more efficiencies, more synergies. But then this pandemic happened. And even though I had already started Geeks That Speak, it gave me an even grander purpose, because I was watching misinformation leading people to make decisions that could cost them their lives. So it's just become an even more important thing for me to help take the voices of experts and help them to be heard above the noise of uninformed opinion leaders. So I developed a curriculum, similar probably to some of the things that you teach in your curriculum, to help groups of scientists or even individual scientists be able to take their beautiful data that they've worked for years on and communicate it in a way that is understandable, that inspires people to think, that inspires a new collaboration or even a new job or a new funding opportunity. So it's been a long genesis, but it got solidified kind of in the more recent years.
Nice. When you were talking, Dr. Corbin, it made me think about communicating science to the general population and how sometimes it might be difficult because people often want definitive answers to things. And in science, sometimes there is no consensus on what the answer is. I wrote a children's book, and it was about why my nephew's hair is the way it is. And spoiler alert, there's no consensus as to why his hair is the way it is. And I remember sending it to an acquaintance. He has a daughter, and he said that one of the things he did not like about the book is that there was no definitive answer. And so I'm kind of curious with someone like yourself, you were mentioning how communicating, especially during the pandemic, people were taking in information that potentially wasn't correct. They probably were also thinking, you might be hearing from different sources, different things, and so there's no definitive answer. How do you communicate science in such an environment where people are expecting definitive answers where there may not be any?
Yeah, my goal is not to just communicate science to scientists, because that's kind of what we've been doing, right? And I think about that as like the 1%, we're this little small group of people that talk to each other. But I really feel like it's super critical to get our voices out there to the general public. And I think that what happened with the pandemic is that we had literally a science experiment happening live in real time, watching us going from new virus, what is it, what's the sequence, how do we develop a drug, how do we protect ourselves. And so I do teach about the elements of the scientific method, and why sometimes when we change our minds as scientists, that's exactly what's supposed to happen, because it's not always so simple and direct. And once we learn this, it leads us to a new question that we couldn't have thought about until we got to this point. So it really is an iterative process, and is about taking the best knowledge you have at the time and making the best decision you can. And then giving us scientists a little grace when we say, oh, we thought it was this way, but we did these experiments and now we actually think it's this way. And that's exactly how the process is supposed to work. So I think when you take some time to explain that to people and give them some examples, they're very receptive to that, in my opinion.
Okay, maybe that's something I should have done with that guy that I sent the book to. But it certainly wasn't something I thought at the time. I was just like, hey man, sometimes it takes time to come to a consensus of what the answer is. But would you rather have someone lie to you and say there's a definitive answer?
Yeah, and unfortunately, in the consumer side of things, so products for weight loss or hair restoration or what have you, when those are being marketed, they're being marketed as we have the answer. It's clinically proven. And I sometimes have to explain to people, what is a clinical trial and how do you prove something? And how could you get an answer that maybe is misleading because you didn't have the appropriate control group or you didn't study the right population? So I really think science literacy is super critical. And it's not just the general public. We really have to start in schools and working with kids and getting them to be curious and inquisitive, rather than taking something they see on a social media channel and taking it as gospel. And that's some of the other things I teach. I interact with kids as much as I can because they're our future, right? We really need to teach them about thinking and pausing before just taking something at face value. That is good, not just for science, but for society, because right now we have a lot of divisions simply because people are willing to die on a hill and are not willing to look over at the other hill and say, wait a minute, there might be some value in that. Because they're just not taking the time to take in the whole picture. So I think critical thinking and science literacy is something that we need to start in schools, and then we need to continue to connect with our communities and help them see how science can be of benefit, and really how the scientific process is good for life in general. I mean, I have a hypothesis about everything. So whenever there's a problem, I have a hypothesis of why there's a problem with my refrigerator. And I think about what experiments do I do to test my hypothesis. Eventually, I might go get the repair person. That's probably the right answer. But, just using those steps of critical thinking, of develop a hypothesis, test the hypothesis, evaluate the results, that helps with life in general. So I'm super passionate about getting that out into the world as well.
Yeah, I think you're right about reaching the children early. And with regards to the acquaintance I sent the book to, if I ever was to come across his daughter, I would say, don't be like your dad.
That's right. Just, give it a little thought. I gave a talk once, and one of the calls to action I had is, whenever information hits your face, which it's happening all the time now, right? Before internet and phones in your hand, the information flow and the flux of it was much slower, right? You might get something at the 6 o'clock news, but now we have information all the time, constantly. So just the first thing to do is go, that's interesting. Let me learn more and dig a little deeper into what's the source of this, first of all. That's like step number one as a scientist. When somebody says this nutrient has this effect, okay, let me find the studies that define that concept. So it's really the same with everything else. Where did it come from? Is there an alternative point of view? And how did we get to that point? And then what do I think is best for me based on having done a little bit of homework as to where that information came from and its validity? And also, reach out to experts, whether it's a public health person or a clinician, or as I say, your friendly neighborhood scientist. I mean, ask me. I will be happy to tell you what I know. Nothing gives me more pleasure than to be able to share something I know with someone and help them.
Yeah, I think you're absolutely right. But hopefully when someone comes to you and asks you for what you know, you have an answer for them, because if the answer is I don't know, then they may very well say, see, this is why I don't ask no damn scientist anything.
Well, a lot of times it's going to be, I don't know. And here's why I don't know. And here's what we do know. And here's the experiment we need to do to answer that question. Or here's the type of study that needs to be done to answer that question. So, if science was easy and if we could have it all figured out very quickly, then we would. I mean, I would be more than happy to have a solution to obesity, to diabetes, to fatty liver disease like tomorrow. And if I had it, I promise I would tell you what the solution was. But the reason we don't is that the human body in general is just a complex integrated machine, and we all have our little nuances of what's different. So this diet may work for you, but it may not work for you. And here's some reasons why, and explaining those reasons why sometimes can help.
Yeah, ain't nobody trying to hear that. Give the damn answer now.
Truth.
Dr. Corbin, when you were talking, it also made me think about giving presentations in front of people and the struggles that a lot of technical people have with that, especially when they're talking in front of non-technical audiences. So a question I typically ask people is, do you have a process for putting your presentations together? And if so, what is it?
Yeah, I do. So I myself, and I encourage the people I work with to first think about your audience and think about what they know, what they come to the table with essentially, and what they would benefit from knowing. I think technical people usually focus on their data and what they think is cool and what they want to get out there. And they want to tell you everything they know about whatever the topic is. Instead, if you want to really engage with an audience and teach them something, you need to think about what they know, what they would benefit from, and craft a clean and brief story around key pieces of science that you want to tell them. So not the whole kit and caboodle, but what are maybe the 3 things that you could teach them that would create this knowledge base for them that they would find beneficial and interesting. So those are some of the things that I teach. And, I think one of the most basic things that I actually didn't believe was important in the very beginning is practice. And the reason I say that I didn't believe it is because my first experience with a phenomenal science communicator was in undergraduate school at Florida State University. And when I saw my mentor give this talk, like my jaw was on the floor. She was poised. I could understand her. And I was just, like a sophomore and undergrad. And she was talking about neuroscience and metallothionein 3 and all this stuff that I literally knew nothing about. But I came out of there inspired and having learned something. And so when she got off stage, I said, how'd you do that? And she said, practice. I was like, no, really? Like, how did you do that? And she said, practice. And I walked away thinking, she's got something that I don't have because I can't do that. And after years of practicing and honing my craft, I realized she was 100% correct. So I encourage that a lot, is to practice out loud, either in front of people or record yourself. And that already takes your nerves down a notch. And when you go deliver the presentation, you come out much more polished because you're comfortable with your material.
Yeah, I'm a big fan of that too. I have a friend, and he makes fun of the fact that I'm a big fan of practicing my presentations before I give them, because he often goes off the cuff. But I'm sure if anybody was in the audience for one of my presentations and one of his, you absolutely could tell the difference, because with him, there's a lot of ums. He has a lot of filler words. And I remember actually this particular guest this particular person was a guest on my podcast, and my mother happened to have listened to that particular one, or at least she started to. She emailed, she called me after trying to listen to it, and she said, your guest used so many ums, I found it so distracting, I couldn't finish the episode. I thought, damn.
I completely agree. That's also part of my curriculum, is to talk about those nonverbal cues, whether it's body language or whether it's fillers that aren't really part of what you're trying to say. They just take up space and distract people.
Yeah, I mean, when it comes to, for me, when it comes to practice, I really like it because, especially if you're given a certain amount of time, you can practice it to make sure that you fall within the time. Because at least that's a pet peeve of mine. If someone is given half an hour and then they go, 40 minutes, it's just like you went longer than I was anticipating you going, or how much you had. I just think it's disrespectful to the audience to go over time. And then not only that, but then you figure out the best way to present the information, or at least you have some time to figure it out. Maybe I say this part first and then this part second. At least when you're doing it off the cuff, it's just coming out as it comes out, so it may not come out in the most efficient way.
That's true. And there's a reason why TED Talks are short, because if you craft your story in the right way, you can really take people through a thought experiment in a relatively short period of time. And let's face it, people have competing demands, short attention spans. If you can deliver something in 20 minutes and you had 30 minutes, great. You gave them some time back. You got your point across. There's time for questions. It doesn't feel rushed. And for me, I was either going to be a dancer or a scientist, and I picked science, which is probably a good thing, although I was a pretty good dancer. And practice was a huge part of being on a competition team and winning national championships. And my dance coach would say, practice like you're going to perform, meaning you don't just sort of like halfway do the kick or the turn. You do it with everything you have, with the smile, with the sharpness, with the emotion, with all of it, because that's how you'll perform. And so when I give talks, I look at how I'm using my hands. Am I going like way crazy? How is my tone? How's my inflection? How's the story? Does it make sense? Or do I go, boy, that came out and that order didn't feel right? So all of those things will then lead you to a quote unquote performance, which is essentially what it is. That's engaging, that's polished, that is timely, and that gets the audience out of there like, boy, I'm glad I spent that 30 minutes there, not going, oh geez, I wish I could get those 30 minutes back.
Absolutely. When I first put together Teach the Geek, one of the motivations was the talks or the conferences I used to go to when I worked as an engineer. And especially if you go to some of those lightning talks, maybe they're supposed to be 10 minutes each. I mean, if you go in there sleepy, you're not going to come out of there alert. You're likely going to fall asleep, because they just weren't the best at putting things together in such a way that could really engage an audience and really keep them, on the tip of their toes. It was pretty bad. So I really wanted to help people with that too. Dr. Corbin, this has been really great talking to you. Thank you for being a guest. How can people get in touch with you?
So I'm easy to find on social media for them to go, Google Karen Corbin or Geeks That Speak, and they'll find me on Twitter, LinkedIn, Facebook. I have a website as well, geeksthatspeak.com.
Wonderful. Well, everyone, that marks the end of another edition of Teach the Geek. I am Neil Thompson. I'm the founder of Teach the Geek. It's an online platform for science and engineering professionals. And I offer some tips that you can potentially use in helping you in your presentations, and you can get it at teachthegeek.com/tips. Again, that's teachthegeek.com/tips. Until next time, take care and stay safe. Thank you, Dr. Corbin.
Thank you. Bye-bye.